Welcome back. We're starting a new chapter, chapter 10. This is going to be on conic sections, an extension really of quadratics. But before we go into it, we have to do a little review of coordinate geometry. You've been here before, so this will feel very familiar to you. So let me get started there. We're going to find the distance between 2 points in a plane. So on any flat surface, if I have 2 points, I can always define a straight line. We do remember what happens if we put a third one in. If that's not exactly straight, then we can't define one line with that. But now we know something we can define if we happen to have 3 points which are not collinear. 3 points which are not collinear. Will yield us what? A parabola. You can always fit a parabola to that. And every parabola can be described with a quadratic equation. So that's a little reminder of what we just left. Now let's go forward into, as I think about it, we're going forward into the past because here we are at geometry, which is where you were last year. So the distance between 2 points, we have a formula for that. Perhaps you remember it already. Then finding the coordinates of the midpoint of a line segment. So if we know that we have a, well, that's weird, can't get my pen, but I had red. Oh, there they are, they're just slow. If I have 2 endpoints, well, let's say 2 points, and I define them to be the endpoints of a segment, then I can find the midpoint. It's going to be, let's say it's right here. Right here. Then this distance here and this distance here are exactly the same. And you may remember how we find those coordinates of the midpoint. Read this one. It is a strange word, isn't it? We should look it up. Maybe some of you in your language studies can dissect that word for me. Coordinate geometry. Today in this little review we're going to be talking about the Pythagorean theorem. We're going to be using it a lot, not only in this first section but in the rest of chapter 10. We know this. This is the this is going to be one leg. Let me draw something here. So we have one leg, we have another leg. Of course, those are straight lines. And we have the line that connects them. Notice that the legs are at right angles to each other. So this is A, and this is B. I could just have easily said this was A, and this was B. That doesn't matter. But this one matters a lot. C is the hypotenuse. Notice that it is always the longest side of a right triangle. Okay, so find the length of the hypotenuse with sides 3 and 4. 3 squared is 9. 4 squared is 16. Add those together, we get 25. Now 25 is representing c squared. If c squared equals 25, and I'm interested in what the hypotenuse is, I need to know what c is. So I'm going to take the square root of both sides. Now we know I do plus and minus every time I take a square root. In this particular instance, the minus has no meaning. We're not going to have a negative value for the length of a hypotenuse. C is equal to 5. Now, this is one of, maybe it is the most familiar Pythagorean triplet, the 3, 4, 5 triangle. It can help you, save you time if you are familiar with that. You'll see it coming up again and again. Okay, we'll have a little word problem. I know you love them. We're going to do it. If a beetle is 6 feet away from the base of an 8-foot tree, so it seems to me we ought to start drawing a picture. And I think I should use color. I probably should have had a little beetle ready, shouldn't I? So I have, let's say, a little beetle right here. How many legs would a beetle have? Well, on one side they'd have 6, right? It's an insect. And I should mark down my dimensions. So here's, we'll call, let's draw a line. That's a straight line. Use your imaginations. And it's at right angles to the distance that the beetle is away. And this is going to be a straight line up to the top of the tree. We have a right triangle here. We have 6 feet. The tree we know is 8 feet. That's given to us. How far if the beetle were to fly to the top of this tree, how far do they have to fly? Well, one leg is 8 feet long, so we're going to say 8 squared, 64, plus 6 squared, equals c squared. So I've got 100 equals c squared. And when I take the square root of both sides, plus or minus actually, I'm going to write that in, even though we're not going to use negative. Negative doesn't make sense here. I'm only writing it in as a process because it's so easy to forget that in other situations. We have c is equal to 10. Something I want to point out to you. Remember I was telling you how important the 3, 4, 5 triangle can be? Notice this. 8 is 4 doubled. 6 is 3 doubled. And 10 is 5 doubled. This actually, when you look at the proportions, 3, 4, 5 is that very useful 3, 4, 5 triangle. Okay, we're going to jump in now to the real lesson, coordinate geometry, finding distances. I have a point at 2, 3. Is that right? Over 2, up 3. And I have another point at 7, 11. Sounds familiar. Which is over 7 and up 11. Excuse me. What is the distance between these 2 points? Straighter than usual. And if I draw this into a right triangle, since remember the Pythagorean theorem is only useful for a right triangle. If you have any other kind of a triangle, it doesn't work for us. Oops. Okay. So we do have a right triangle. Notice how I constructed the legs. This is x, right? This is the distance from this point to this point horizontally. And this is y, the distance from this point to this point vertically. Now, that's what we're going to use. We're going to say one leg and square it plus another leg, square it, is going to equal the distance squared. Well, this isn't really right, is it? It's not x. What is it? If I refer to this as x sub 1 and y sub 1, and up here I refer to this point as x sub 2 and y sub 2, really I should be writing this distance, right? X sub 2 is here at 7 minus x sub 1, which is here at 2. So I'm going to square that distance of the leg. Oops. What? Now, x sub 1 plus, and now the distance of the other leg squared, which is y sub 2 minus y sub 1, doesn't look like a minus, the distance squared. I want to point out to you right here that it doesn't matter which I have first. When I square this, it's going to make whatever it is positive anyway. I could have had x sub 1 minus x sub 2 squared and y sub 1 minus y sub 2 squared. I'm going to get the same distance. All right, I know what this is. The distance from 2 to 7 is 5. 5 squared. The distance from 3 to 11, 8 squared. So let's see, my distance is equal to, we know we're only going to be interested in the positive, the square root of 25 plus 64. That's going to be the square root of, we add those two together, what do we get? 89. I could figure out what the decimal is. And if I were doing a project at home or something, the square root of 89 is not going to be useful to me. I need to convert it into decimal. I'm not going to do it here because you all know how to do it. So coordinate geometry, finding distances. The b is going to equal, if we can put it on a coordinate plane, drop this whole thing onto a coordinate plane, is going to equal the coordinates of this point. And what are they? We don't know. All right, so we're going to call them x sub 1 and y sub 1. When we don't know what a value is, that's where these letters come in handy. They weren't actually invented just to make your life difficult. They're actually invented to make your life easier. It's just learning it is a little bit difficult sometimes. So b, which is our vertical distance, is going to be y sub 1 minus y sub 2. Now I purposefully put my larger value as the first one, and then my a would be x sub 1 minus x sub 2 if I drop this onto a coordinate plane and I got points for here and here. By the way, if these were my points here and here, what would the point coordinates be for right here? This is sort of outside the lesson, but what are they? Well, I know what my x is. My x is x sub 1. I get it from right here, right? And my y, it's in line with this one. So that's just a little enhancement for you. You knew that anyway. Okay, so here we have dropped a right triangle onto a coordinate plane in order to use a coordinate plane to help us find what the length of the hypotenuse is. Finding distances. I think we've already done this. We're going to be able to scoot right through this thing. Whoops. This is just what we were looking at before. We take this triangle and we drop it into a coordinate plane. The beauty of that is now we have point coordinates that we can use for figuring the distance. We know how to do it. Basically, here's your distance formula. If you're going to write something in your notes, of course, what am I saying? If. As you write your notes, you want to take a moment right now and make sure you get this into your notes. This is so critical. The distance is the square root of one leg squared plus the other leg, the horizontal leg plus the vertical leg. So we're going to try doing it right now. We're going to use the distance formula. We know it's based on the Pythagorean triangle. I'm going to try, there's something here called the magic pen. No, that's not it. That's not it. This is it. I'm going to try the magic pen today. I'll see how this works. So I have interest in knowing the distance between those 2 points And I know that if I set up a right triangle using my grid, I can use the Pythagorean theorem. So my distance is equal to the square root of, let's see, which point is which? Negative 5. 1, 2, 3, 4, 5. Okay, so this is negative 5, 5, and this is negative 3, and this is below y equals 0, negative 1. So the distance between those 2 points, I'm going to take negative 5, and from that I am going to subtract my other y-coordinate minus a negative 3. We know what's going to happen there, right? I'm going to square that plus, so what did I just do? I used my x coordinates. Now I'm going to do the y coordinates. I'm going to go in the same order. It is smart to be as consistent as you can. Methodical keeps you out of trouble. 5 minus a negative 1. This is a positive 5 minus a negative 1. So my distance is equal to the square root of, let's see, negative 5 minus a negative, so it's going to become a plus. So negative 5 plus 3 and over here a positive 5 plus 1 so I end up with the square root of 4, right? If I square any negative, it always becomes positive, plus 36, which is equal to square root of 40. That should be simplified. If you have a perfect square, you should factor your radical, and then write it in the simplest possible form. Again, if I were trying to do some real project of measurement, which in some situations you are, this 2 square roots of 10 is not a useful number. You want to convert that into decimal. Midpoints. Now, midpoints are a different animal, but they're using the coordinate plane again. And I have, in this case, my endpoints are at 1. That's my horizontal, my x, and 1, 2, 3, 4, 5, 6, just as I expected. And this one is at 5, 8. I want to find the midpoint. Let me get a different color. So the midpoint, I can see where it is on my graph, so I already know what that's going to be. Don't you? It's going to be 3 and 7. That's my midpoint. So how do I do that with my point coordinates? well, this is the way to think about it. The midpoint is the average of your x-coordinates and the average of your y-coordinates. So just add them up. Remember now, when you're doing different distance, you're looking at difference. When you're doing midpoints, you're looking at sums. You add them up. 1 plus 5 gives me 6 over 2. That's my midpoint's x-coordinate. My midpoint's y-coordinate is 6 plus 8, or 14 over 2. I would not leave it like that. Let's simplify it. 3, 7. Just what we expected it to be. See you in class.